Hello, I'm continuing on how to use Python and solve some simple mass and energy balance, but we are still on mass balance. In my previous videos, I've shown you how to use Python and solve a simple mass balance where there's no reaction. So today I want to go further and tackle a reaction. So we have a reactor where a reaction is taking place, definitely. We have A to be our reactant, and we have B to be the product from the sketch that I did here. So we have our entering flow rate, volumetric flow rate to be 15. We have our entering concentration of the reactant to be 2.5 mole per liter. So we have the volume of the reactor to be 150 liter. So the question is calculate, or the question is to use Python to find the output concentration of the reactant Ca, and we have to also find the output concentration of the product B. So on this video I'll show you how to find the Ca, and the next video I'll show you how to find the Cb. So if you can see here, I've simplified through my mass balance. I've simplified the Ce using to this form so that I can code this on Python to give us our answer, as simple as that. So let's start. So my Python is open. So I'll start by defining my parameters. Hash para hash parameter parameters. Then I have to define my flow rate, a volumetric flow rate, which is F naught, which is F naught is what I think is 15. So 15, no, it's 15. Then I have to define my unit, which is liter per minute. Good. Then define my engineering concentration, Ca naught, Ca naught, which is 2.5, 2.5. Then hash mole per liter, so mole per liter. Okay. After that, then I have to define my K, which is the reaction constant. My K is what? 0.85, and the unit is what? Per minute, so it's 1 over minute, 1 over minute squared. So I also define my volume of reactor, which is V, which is equal to 150. Then I'll type hash liter, definitely, because it's volume. So from here, I'll type enter. Then I'll define my Ca, what I want to calculate, the steady state concentration of the reactant, which is A. So I'll define my steady state concentration of the output reactant. Good. So that one will be C dash A will be a cosine, then open. Then I'll define my equation, the simplified version. This one I'm typing right now. I'm typing this one. That one is my steady state concentration of the A. So I'm typing this one on Python right now. So it should be F naught multiply by Ca naught, Ca naught, bracket close. Then I'll divide by FA naught plus VK. So it will be F dash naught plus V multiplied by K. Good. Then I'll close the bracket. Then I'll type enter. So now I'll tell Python print, then open bracket, then mod output output steady state concentration of what C dash A. Then I'll press equal sign, then dash, then open comma. Then I'll type this CA now. I'll type this one where my arrow is. This CA, I'll type it there because this is what I want. So CA. Then I'll close with comma. Then I'll type the unit for it, which is mole per liter. So it's mole per liter. Then I'll close my brackets. Then I'll type enter, which is it said the output steady state concentration CA is what 0.23. You can solve it with hand, you will get the same answer. So see you later. See you next video where I will calculate the CB.